Hey kids, welcome to section 2.1 functions and continuity. Today we're going to learn how to determine whether a relation is a function and then determine whether functions are discrete or continuous. Lots of new vocab today, so make sure you're paying attention. Alright, so first, what is a relation? A relation exists when there is a relationship between the domain and the range. Now, in case you don't remember, the domain of a function is the set of all x values, and the range is the set of all y values. So a relation is just a pairing of x's and y's. It can be a table, it can be a list of ordered pairs, it can be a picture, it can be an equation, any kind of relationship between them. Now, there are some relations that are special. Those are called functions. A function is a type of relation in which each element in the domain is paired with exactly one element in the range. So that means you can have 1, 2, and you can have 3, 2, but you can't have 1, 2 with 1, 1. So this is a good function and this is not a good function. So the point is that you want your x's to always be paired with different numbers. Here in the nose, the x's are both 1s, but they're paired with different y's. Over here, it's okay that the y's are the same. You just want to make sure that each x is being paired with a different y. You can use something called the vertical line test to determine whether the relation is a function. So what the vertical line test allows you to do is you can look at a picture of the function, and if you can draw a vertical line up and down and it only crosses the picture one time, that is a function. If I look at this picture over here on the right, if I try to draw a vertical line, it's going to cross 2 times. Now you might say, well, Yanka, I can touch right there only one time, but the point is anywhere else you'd be touching more than once. So knowing that the vertical line test enables you to figure out if things are functions or not, that's a useful tool. Now we also have to learn about 2 more vocab words, discrete and continuous. A relation in which the domain consists of a set of individual elements and the graph is a set of unconnected points is said to be discrete. So if you look over here, graph A is discrete. It's a bunch of individual unconnected points. When the domain of a relation has an infinite number of elements and the relation can be graphed with a line or a smooth curve, the relation is a continuous function. So graph B is a continuous function. All the individual dots have been connected into a smooth curve. So visually, discrete is dots. Continuous is some kind of curve. All right, let's look at an example. Relation A and relation B are graphed below. Which must be true? Okay, option A, only A is a function. Well, let's take a look. Here's option A is this parabolic function. Is it a function? Well, if I draw a vertical line, I don't know, if I draw it right here, it crosses once. If I draw it right here, yeah, I think A is a function. Okay, what about B? Well, B is this line that goes like this. If I go here, I'm crossing it once, okay? If I go here one time, here one time, I think B is also a function. So is only A a function? Is only B a function? Both are functions. Neither are functions. I'm going to go ahead and say C. Both are functions. All right, so let's do some more vocab. State the domain and range of each function, determine whether each relation is a function, and finally determine whether each relation is discrete or continuous. I guess this word right here should be relation, because we don't know if it's a function or not. Okay, so let's look at letter A. Well, the domain is all your x values. So let's see, our x values are -4, -3, 0, 1, and 3. So we're going to put those, it's best to put them in smallest to biggest order, but it's not necessary. It's just easier to check. All right, your range is all your y values. So we got -2, 1, 2, and 3. It looks like -2, 1, 2, and 3. Remember, your y values are the second numbers. Okay, determine if it's a function. All right, if I draw a vertical line, am I going to cross more than one point at a time? And the answer is no, so this is a function. And then is it discrete or continuous? It's a bunch of dots, so it's discrete. All right, letter B, domain. So this time we have a bunch of ordered pairs, but I have not been told what the ordered pairs are, so I'm going to have to count. So let's see, domains start with the x's. It looks like -1, -2. I have -3, -2, -1, 0, 1, 3, and 4. Okay, that's a lot. So -3, -2, -1, 0, 1, 3, and 4. Notice that -1 or -2 has 2 ordered pairs that fall with that, but notice I only wrote it one time. You don't want to repeat numbers in domain and range. Okay, range is all the y values, so I'm going to start at the lowest y value. It looks like -3 and -2, and that's a -2. That doesn't look very good. Let's make that a little nicer. Okay, and then I got 1, 2, and 4. Again, they don't have to be in order pair, it's just easier, or in order. Let's see, is it a function? Well, actually it's not, because if I draw a vertical line right here, I'm crossing 2 points, and I can't do that. So this one is not a function. And then is it discrete or continuous? It is discrete because it is a bunch of dots. Okay, letter C. This is called a mapping. If you've never seen a mapping before, it puts all the x values on the left and all the y values on the right, and then draws arrows to show you which x's are connected to which y's. So like -3 goes with 0, -2 goes with 2, -1 goes with 6, 0 goes with 4, and 1 goes with 6. Notice nothing goes with 8. Okay, so domain's in the x values, which is the one on the left. So I just have to write -3, -2, -1, 0, and 1. My range is 0, 2, 4, 6, 8. Okay, this is function or not a function. Well, is each x value going to exactly one y value? And the answer is yes. So this is a function. However, these are just ordered pairs, so it is discrete. Okay, finally we get to letter D, y equals 2x plus 1. This is a graph of a linear function, so it starts at 1 and it goes up to over 1, so it kind of looks like this. So notice that the domain and range is a little bit more challenging. We have to think about it. It is not just a bunch of ordered pairs, so it is not just a list of all the x values. Think about this line goes on for forever. It goes on for forever in the side-to-side direction, and it goes on for forever in the up and down direction. Well, going on forever means that it goes to infinities. So your domain is going side to side to infinity, so negative infinity to positive infinity. And your range is going up and down for forever, so negative infinity to positive infinity. Notice the smaller infinity goes on the left, bigger infinity on the right. Notice we use parentheses because anytime we use infinity symbols, we always use parentheses. Notice that if I try to draw a vertical line, this is going to pass the vertical line test. Every x is only paired with one y, so this is a function. And these order pairs are connected. This is a continuous function. Okay, let's do a little bit more vocab. Graph the given relation, state domain and range, determine whether the relation is a function, and then state whether it's discrete or continuous. Okay, look at letter A. First, we're going to graph the given relation. So we're going to start at -3 on the y-axis. Our slope is 1/2, so up 1/2. I don't really need to see where they're crossing or anything, so I'm just going to draw the picture. Okay, next says to do domain and range. Well, domain is all your x's. This is going on for forever in the right and left direction. So my domain is everything, all real numbers, negative infinity to positive infinity. My range, well, my graph is going forever in up and down, which is positive and negative infinity. So smaller number first, negative infinity to positive infinity. Is this a function? Well, it does pass the vertical line test. Every x is paired with only one y. And all of these are connected. This is continuous. Okay, letter B, we have some order pairs. So 2, 6 would be right 2, up 6. 6, 2 would be right 6 and up 2. 3, -1, and 2, -2. All right, so our domain is going to be a list of x values. Let's see, we got 2, 3, and 6. Your range is a list of y values. -2, -1, 2, and 6. And it's okay that there are 3 numbers in the domain and 4 in the range. It just, you don't want to repeat stuff. Is this a function? This is not a function. Notice that if I try to draw a line right here, I go through 2 dots at the same time, so this is not a function. And since these are a bunch of dots, this is discrete. Okay, so now that we've learned what a function is, we've learned about domains and ranges, let's see what we can do with functions. So when an equation represents a function, the variable, often x, with values making up the domain is called the independent variable. So the x values go with the independent variable. The other variable, y, is called the dependent variable because its value depends on x. Here's what we now call function notation. Anytime you see this funky looking symbol, you're going to think of it as function. And the way you read it is it's called y equals f of x. F of x. So these parentheses mean of x. The x is your input, the y is your output, and the f is the name of the function because you can have more than one function at a time. So we're going to figure out, given g of x equals 0.5x squared minus 5x plus 3.5, find each value. So what we're doing, kids, is we are looking at a function. This is a parabolic function because of the 2. And what we're going to do is we're going to substitute in an x value, and we're going to get out a y value. And that's a point that's going to be on the parabola. So if I want to find g of -2, I'm going to take -2 and I'm going to substitute it into the equation every time I see an x. 0.5 times a -2 squared minus 5 times a -2 plus 3.5. Replace every x with -2. And then you're going to simplify. So this is -2 squared is 4 times a half is 2. -5 times -2 is 10 plus 3.5. That gives me 15.5. So if I were to go and graph g of x on my calculator and go to x equals -2, I would see a dot at 15.5 on the y. Because remember, g of -2 is really like saying y equals. All right, let's try another one. Let's do g of 4a. So remember, this x is being replaced by 4a. So we're going to do 0.5 times 4a squared. Notice I put the 4 and the a in parentheses, just like before I put the negative and the 2 in parentheses. Minus 5 times 4a plus 3.5. Okay, so if I want to do 0.5 times 4a squared, Well, first you have to square the 4 and you have to square the a. So that's like saying 16a squared. And then if you multiply by 0.5, you get 8a squared. Then if you multiply negative 5 and 4a, you get minus 20a plus 3.5. None of these are like terms, so I cannot do anything else. All right, let's move to a different function. This time our function is f of x right here, and we're going to find each value. So find f of negative 2. So we're going to plug negative 2 into the function for x. Be careful with your signs. So on the top of the fraction, I have negative 2 plus 2. And on the bottom, I have a negative 2 minus 3. So the numerator gives me 0. Negative times a negative 2 is a positive 2. Minus 3 is negative 1. Well, 0 divided by anything is 0. Don't believe me? Divide it on your calculator. All right, letter D is f of u. So we're going to go to our f function and we're going to plug u in for x. So we're going to get u plus 2 on the top, and we're going to get negative u plus 3 on the bottom. And oh, my bad, that's a minus on the bottom. That is it. You cannot do anything else. You cannot say, oh, the u's are the same, I'm going to cancel them. Or, oh, look, the two negatives. No, that is it. That is all you can do. All right, let's do some word problems and some graphs. The graph for number 5, the graph shows the length of the Tour de France in kilometers each year from 2000 to 2013. So year 2000 to year 2013, we have the distance of the Tour de France. Weird that it changes. Is the relation discrete or continuous? Well, it's a bunch of dots. That means it's discrete. Continuous would be connected. Does the graph represent a function? Well, we need to see if it passes the vertical line test. So are there any dots that are vertically stacked above any other dots? And the answer is no. So this yes represents a function. Each x is paired with exactly 1y. So if it says justify your answer, if it says give a reason why, you're not just going to say passes the vertical line test. Like, what does that tell you? You're going to say that each x is paired with exactly 1y. Okay, number 6, the number of employees a company had in each year from 2010 to 2015 were those 5 numbers. Graph this information and determine whether the relation is discrete or continuous. Okay, so first we have to decide, do the 2010 to 2015 numbers go on the bottom or do they go on the vertical? And the answer is time is always the x's. So we're going to put, let's see, we'll do this first one as 2010. Skip, let's do 2011 and then 2012, 2013, 2014, and 2015. Let's erase that first one and just make it a 10. Be way easier. Okay. And then let's see, these are my years, so we always want to label our graph. And then these are the number of employees. Okay, so we need to go from 25 up to 34. So the vertical goes up to 20. So if we count everyone as 2, so there's 2, 4, 6, 8, here's 10, 12, 14, 16, 18, here's 20, 2, 24, 26, 28, here's 30, and then this would be 40. So our first 2010 goes with 25. So let's do 22, 24, 25 would be like right here. And then 28 is going to be right here. And then 34 right there. And 31 right there. And 27 and 29. There we go. So discrete or continuous? This is discrete, bunch of dots. Does the graph represent a function? Are there any dots vertically stacked? And the answer is no, dot stacked. So yes, it is a function. Each x is paired. Each x is paired with exactly one y. That is your justification. All right, let's look at word problems to see if they're discrete or continuous. Number 7a, the Yogurt Shack sells prepared cups of frozen yogurt for $2. The cost of x cups can be described by the function y equals 2x, where y is the total cost in dollars. Determine whether the function is correctly modeled by discrete or continuous function. Explain your reasoning. Okay, take a look at the x cups. Think about if your cups of ice cream or yogurt can be decimals or fractions. And the answer is no. You cannot walk in and ask for 2.5 cups of yogurt. They will either give you 2 cups or 3 cups, but you cannot get half cups of yogurt. Therefore, this is a discrete function. You can only order whole cups of yogurt. Only order whole cups of yogurt. No half cups. So no decimals allowed, which means you can only have certain values for x, which makes it a discrete function. Letter B, a graph consists of the number of hours x a car travels and the distance y the car travels. Determine whether the function is correctly modeled by a discrete or continuous function. Explain your reasoning. So your x values here are the number of hours a car is traveling. So ask yourself, what kinds of numbers can you have for how long you've been traveling? Well, you can have 1 hour, you can have 2 hours, you can have 3 hours, but you can also have 2.5 hours. And so since you can have decimals and fractional parts of hours, this is a continuous function. Let's see, can drive half hours, not just whole numbers. Not just whole hours, we can say. So trying to figure out if your x values are going to be whole numbers or fractions can also help you decide if the function is going to be discrete or continuous. All right, kids, that is the end of section 2.1. If you have any questions, please let me know. And as always, keep calm and keep trucking.